Good morning, everybody, and welcome to another UC Davis CSIM Center webinar. Before I get started today, I just want to do a couple of quick pieces of information about this stream. First off, there's a chat window to the right of your video. If you have any questions throughout the video, go ahead and put them in that chat, and I will do my best to answer them. One thing to note is that there is a several second delay between when I start saying something and when you will see it. So if it seems like I'm taking a little while to get back to your question, it might be partially contributed to by that delay. Another thing that I do want to note is I'm doing my best to make sure that these videos are available to be watched afterwards. So be sure to tune in and keep paying attention for our most up-to-date webinars. So for today's topics, I'm going to talk mostly about our elementary school curriculum that exists within RoboBlockly, and RoboBlockly is our drag and drop coding environment that is really built from the ground up with the whole goal of helping students learn their math, their robotics, their coding skills, and all these valuable concepts, critical thinking, logic, reasoning, and really build from there through a bunch of interactive activities, through some hands-on robotics, and really prepare them for when they might in the future transition into a written coding language. So to get started, if you wanted to get a RoboBlockly account, what you would have to go to do is c-stem.ucdavis.edu. And once you are on the CSIM website, at the very top here we have this golden bar that says free resources for distance learning. If you click on that, it's going to take you to a bunch of information that we have about getting started with distance learning. From this page, on the left-hand side, there's a register link. If you click on that and fill out this form, K-12 teachers and educators are eligible to receive a free RoboBlockly account during these closures. So once you have your free RoboBlockly account, you can go to roboblockly.com and you'll click on the sign in button, which is going to appear right here in the top left. And once you click on sign in, it's going to ask you to sign in with your email address and password. So I'm going to sign back into my account now. And really what this RoboBlockly account does is it gives you access to our classroom management portal, which I did a webinar on yesterday and went through all of the details for how to create a class in the classroom management portal and to create assignments. It also gives you access to our full curriculum and a number of additional features that really do help to go beyond just basics of coding and math and create a much more interactive learning experience for the students. Let's see if I can, there we go, I finally got it. So once you're logged in, there's a couple of things that I do want to point out before I start diving into the curriculum. First, for really young students, this interface could be a little bit overwhelming. First, there's lots of words everywhere, which if you're in kindergarten or first or second grade, you're just starting to learn how to read, and it can be a bit overwhelming looking here. So we have a couple of ways that this interface can be simplified for younger students. The first is in the middle here. This is our block menu. This is where all of our commands for the robots that we're simulating here, or really anything that we're doing in this simulation are. And at the top of our blocks, we have this little drop down here. Mine right now is set to symbol plus word. And what that means is all of these blocks are going to have a little symbol icon that will demonstrate what it's going to do or really represent what that command is going to do, as well as the name of the command next to it. If I switch to just word, it's going to get rid of that symbol. And then if I switch to just symbol, it's going to only be a really short one-word description plus a symbol to represent what that command is going to do. So again, this can be really useful for simplifying that interface a little bit for your students. The next thing that I wanted to point out is the settings menu underneath of our simulator. So this little square here, this is our simulator with all the controls here to start over, to run, step through, etc. Underneath of it, we have a bunch of robot setup and grid setup for changing all the different settings of our simulator environment. And so what we might want to do is remove some of this and clean up the look just a little bit so it's a little bit easier for the student. That we have at the top here that really most elementary students aren't going to be using anyway. And once you switch it to simple view, as long as you don't go into any activities that require the full view or anything like that, it will stay as the simple view until you change it back. So if I were to refresh this page, I can hit the F5 button on my keyboard. It'll refresh and you'll see I still have the simple view. I'm still on the symbol blocks and everything is set up exactly as I had it. So the next thing that I also want to point out is if you're learning RoboBlockly for the first time, not really sure what to do, at the top right we have this tutorial section. If you click on tutorials, it's going to take you to another page with 5 different sections of tutorials. We have interactive tutorials on using RoboBlockly. These are going to go through step by step with pop-up instructions of what to do your first time starting out with RoboBlockly. So I'll just demonstrate what one of these looks like really quick. I'll go through this first one, Introduction to RoboBlockly. Click on the link here, it loads it, sets it up exactly as it needs for this tutorial, and you can see I have this pop-up here. It says drag the drive distance block to the workspace. Well, I can see my workspace is here, so I drag this to the workspace. Show CH to display the CH code. And then what this is going to do is it's going to show me all of the CH written coding that corresponds with this program that I created here. So we're starting to bridge the gap between block-based coding and written coding. Then it says add a turn block to the workspace and attach to the existing block. So I add it to the workspace, but it didn't attach. I have to make sure that I actually get it to snap on there. And it says drag another drive distance and attach to the existing block. So I do the same thing. You can see it's updating my CH code as I go, and now it says you can click Show CH again to not display that code. I can reset my simulator by clicking Reset to move the robot to the original position, so I reset. And then it says I can click Run to watch it run through this entire new sequence. And the orange block is the one that is currently running on my robot. And I can reset, and I can then also step through this step by step, one step, so it only does the drive distance, and then it waits and it says click step again to execute the second command. So I click it again, and then one more time to finish up with that program. Click reset, click step. If I start stepping through and I don't want to click step over and over, it says that I can click continue to finish the program from the current position and finish up the program. It says, wow, you're doing awesome. And it even says, let's advance to the next problem. And I can click next. This next button will take you to the next interactive tutorial and walk you through, again, all the details for getting started with RoboBlockly. In addition to those interactive tutorials, we have a number of video tutorials to help you get started, and video lessons. I'm going to look through the video lessons really quick. These are short videos that we've created to help explain what different functions in RoboBlockly are and how to accomplish different tasks. So for example, we have lessons on robot programming. We have ones for drive distance or set speed or drive time. Continuing on down a little bit, we have lessons for hour of code, such as getting started with moving a robot, repeating with a loop, using variables, moving robots simultaneously. We have a bunch of lessons on coding. We have lessons for drawing and creating animations, generating random numbers. So there's lots of resources and tutorials to help a beginner get started here with RoboBlockly. The next thing that I want to do is dive into our curriculum just a little bit. So from any page in RoboBlockly, we can see at the top left, once we're logged in, we have this curriculum link that's available. If you're not logged in, it'll be grayed out and you won't be able to click on it. So if I click on curriculum, it's going to take me to our curriculum list. And this curriculum list is a set of courses that are designed here in RoboBlockly as sequential collections of activities to help guide students through learning. So we have courses on robotics. We have robotics 1A, 1B, robotics 2. We have courses on coding. So we have coding 1, coding 2. And then we have a number of different math courses. So we have kindergarten all the way up through algebra 1, as well as some free curriculum for Hour of Code, AP Computer Science Principles, getting started with Arduino or LinkBot Arduino, and some more interactive projects with drawing or animations or music or creating games and things like that. So for the duration of the rest of this webinar, I'm going to focus mostly on this kindergarten through 5th grade math. I'm just going to quickly walk through what's available in there, and I highly encourage you to sign up using that form on our website to get your account so that you can start diving through these activities and thinking about what would be most appropriate for your students moving forward with this distance learning initiative. So I'll start out right here at the beginning with kindergarten math, and this kindergarten math course is set up sequentially, and it starts out as low as counting numbers and objects up to 10. We have an activity here that says count the number of passing cars, and this activity is going to animate a random number of cars driving across the screen, as we can see here, and the students would have to count the number of cars that pass by and then type in or select the number of cars that drove by that they saw. We have another one, count the number of eggs up to 10. Same kind of idea, but instead we're going to have a number of little Easter eggs kind of placed throughout the grid, and the students would have to count them up, 1, 2, 3, 4, 5, 6, 7, and answer the question accordingly. We have a different type of activity for supporting this counting, driving forward with 1 block from 0. So we have a robot that would start at 0, and we have to get it all the way to some positions. We'd have to count the number of lines along this gridded number line to see how far the robot needs to move to get to that final position. We also have one that gets back into sports a little bit and says we have to catch a football using 1 movement block. And so we say, all right, the robot starts at 0. This football's at the position 9 here, so we have to figure out how many steps we have to take to get to position 9 to catch the football. I'm going to go ahead and click on this activity here so you can see kind of what it looks like within the activity. I'm going to give it a moment to load here. And so this activity and most of the activities here in RoboBlockly are set up with some sort of a title and a problem statement. So the title here is catch a football using 1 movement block, and then our problem statement is to change the value in the pre-placed block to tell the robot how far to move to get the football, and then click the run button. The robot will start at 0, and we can click the new problem button to try another problem. So if I have a really young student who's maybe not quite ready to read all of this, as most kindergarteners aren't, we also have this play icon here where it will read the problem statement to you so that you don't have to understand how to read all of this. You can jump right in with the activity and the problem statement. You could also look at a hint by clicking on this light bulb icon, or we could click on this little information icon as the teacher to see a bunch of additional information about this activity, such as the grades it's flagged for, which curriculums it is in, and then what standards it is designed to support. So, looking at this activity in our workspace, we already have this drive block that says we're going to drive forward 2. And so if I were to run this, I can see right away my robot is going to drive 1, 2 from the 0 position, and it's going to tell me I got the wrong answer and I have not caught the ball yet. Please try again. And I can use the hint button if I feel stuck. So what I can do is reset the simulator, and I can count out 1, 2, 3, 4, 5, 6, 7. Okay, so the ball's at 7, my robot starts at 0, and I need to move forward 7. So I can change this value in my drive block to 7, And then when I run it, my robot's instead going to drive forward the full 7 units to catch the ball. And if I got it right, any activities that can tell me that they got it right, we're going to give me a little inspirational message saying, awesome job, or great job, or something along those lines once I get it correct. Now, if I wanted to try more practice, I could click on this new problem button, and it's going to randomize the environment. Oh, it looks like I got a little lucky there. If I click new problem, it's going to randomize the position of the football. Now, it is fully random, so you notice I had to click it a couple of times to get it to move. That was just pure luck getting the same position multiple times in a row. And so once I get to a different problem that I want to try, I could do the same thing, count out how far the robot needs to move, and change this to that distance and click run. So it's a pretty simple, straightforward exercise. There's not a whole lot of coding involved yet. We're more building up that critical thinking and counting through these steps. So I'm going to go back to the curriculum portal, back to the kindergarten math, and look just a little bit further. So this kindergarten math is set up in a sequence. We have section 1 here, we go down to section 2, all the way down through the end of the course, and it's organized in a standard progression that you might see for kindergarten math. A couple of additional tips here with these activities. That info icon that we clicked on in the activity, that's the same info icon that we have here. If you click on it as the teacher, it's going to show you all of the same information we saw inside, including the problem statement, so we don't even have to go to the activity to see what the problem is. We also have activities where we'll have to do things like count the number of shapes, like squares, or counting circles or triangles. If I scroll down just a little bit into section 2, we have an extension of counting where we can count objects up to 20. So we can count number of sheep passing by, counting up to 12 instead of the cars. We can count the number of eggs around this circle. We can count the number of Easter eggs that are being set out up to 20 instead of only up to 10. So all kinds of extensions, and really what we're doing is scaffolding for the students so that they start out at something really simple and build from there. From here on, I'm going to go a little bit quicker through these activities, just kind of highlighting a couple of little bits. So in section 3 here, counting numbers up to 100. So find the missing number from 1 to 100. We have a missing number that they have to find. Counting boxes in multiples of 10. So we have 10, 20, 30, 40, 50. Counting numbers not starting at 1. So if we had this robot here that instead of starting at 0, it started at 3, we then have to count from 3. We have counting in multiples of 2, 5, and 10. So we have groups of tomatoes here. We could count 2, 4, 6, 8, 10, etc. Or counting bananas in bunches of 5, or eggs in boxes of 10, or eggs in baskets of 10. We have addition and subtraction within 5, so we can add 1 plus 4, so 1 apple plus 4 apples, 3 bananas plus 1 banana, and all of these activities are really geared towards giving the students a little bit of guided practice. We have addition and subtraction, so subtracting roses. So if we have 4 roses and we take away 3 of those roses, what are we left with? We then also get into comparing different numbers. So we have 2 robots here that drive different distances, and we might have to say maybe which robot went further, or which one went the shorter distance, or how far apart are they? So we'd have to count from one robot to the other. And then extensions of the football activity where we say we have to catch the ball and then score a touchdown. We go into adding within 10, where we say just build off of that previous addition within 5. Go into subtraction within 10, combination of addition and subtraction within 10, where we could say, all right, if we start with the robot at 3, we have the football at 6, and we have to score a touchdown at the end zone at 10, we have to do a little bit more thinking and work through the logic and math to figure out how we're going to get that robot to catch the football and score the touchdown. go into comparing numbers. So instead of just 2 robots, we could go as many as 4 robots and say, all right, if they all went a different distance, we could ask a number of different questions about this scenario to have the students really thinking a little bit more outside the box and more practically with the math that they're learning in their class. So we could say problems such as if this robot, the green robot, only went to 2 and the blue robot went to 8, how far apart are those 2 robots? And then we could say how much further is the 9th robot is the red robot from the green robot than the blue robot from the green robot? And really start to scaffold these ideas and build up from where the students are at. We go into more geometry, identifying and describing shapes. We have activities such as this introduction to common shapes where it'll ask the students what shape they want to see, and then it'll draw it on the screen. Here, I'll show you really quick. If I look through this, it says you'll learn a few common shapes. Click run and choose which shape you'd like to see. So I click run. I choose a shape. Which shape would you like? I want to see a rectangle. And so I click submit, and it draws a rectangle on the screen. If I want to reset and run, and this time maybe I want to see a triangle, it'll then draw a triangle on the screen. And so it's really starting to help with recognizing what different shapes are. Building from there, we go into separating shapes into other shapes. So a square can be split into triangles, for example. We go into a little bit more repetition where we say, okay, if we have this square here, and we want this robot to drive around the square, the robot's going to do a lot of repeated steps. And so it starts out here, and it's going to drive forward, and then turn right, and then drive forward, and then turn right. And it's going to repeat that drive forward and turn right some number of times, and we start building up this repetitive logic and understanding with this. And we even go into a little bit more extensions where we're counting or adding and subtracting within 11. And so we have lots and lots of activities in here to support kindergarten math. I'm going to quickly go through a couple more grade levels here, such as first grade math. We have start with counting up to 20, where we say count the number of passing sheep. And you'll notice some of the activities are repeated from one grade to the next, and that is kind of intentional because it helps to, if the students were working through this in the previous year, it helps to build that connection and practice with what they've already done before, but then it also adds extensions to that, where saying maybe these grid lines are added by 2, so it goes 2, 4, 6, 8, and they have to figure out how they're going to count by 2s all the way up to get to catch that football. Counting up to 120, so we're just extending these activities to be higher numbers and a little bit more challenging. Adding within 10, where we say we have adding within 10 of dogs, we have 6 dogs plus 3 dogs equals 9. Same kind of idea as the other activities that we had in kindergarten. More addition within 20. We have addition tables that we'll work through, where we'll say, all right, if you have this sets of numbers in a table, what number is missing here from this addition table? We can keep going. Subtraction within 10, where same idea with that roses activity. We have 9 roses total. We took away 5. How many are left? Subtraction within 20, just expanding upon that into higher numbers. Combination of addition and subtraction within 10. We're starting to build a little bit more scaffolding here and build up. And so we have things like follow the line to reach the star, where we're starting to add a little bit more dynamic thought process to these activities, where we have this random path here where the robot said looks like it has to go 10 units to the side here, and then it's going to have to turn to the left and go up, 5 units, and then turn to the left and go forward 7, turn to the left and go 3, and then have the students actually start to create this sequence by dragging the blocks into the workspace to see if they can make it to the star. And every step along the way, we have hints or additional information to help guide the students through. Combination within 20, higher levels of those same types of activities, maybe looking at robot speeds and saying, all right, speed limit is 19 minus 16, so what is the total speed limit? That would be 3. Working with addition and subtraction equations, starting to identify different parts of an equation where we have this robot that goes to this red line plus some number is equal to 6, or in this case it'd be 3 plus what is equal to 6 to get to the red line, and then for the blue line it's drive further, so it's 6 plus what is equal to 14. So we start here, how much further does it have to go to get to 14? We extend that a little bit further with subtraction here. We get into true and false statements where we say, is this problem correct? Is 6 plus 12 equal to 18? And the students would have to say yes or no. We get into comparison of different distances, just like we did in the kindergarten level. And we just start going into all of these different concepts here. We get into measuring lengths. So we have this length of a pencil that we might have to measure, going through telling and writing time. So being able to identify what time it is on these clocks, or even set the time on the clocks by telling the minute hands to rotate to different positions. We go into data tables, so starting to represent and interpret data in a table. So we have some snacks here, so oranges and apples, and then we say, all right, if we have 4 oranges in this row and then 3 apples in that one, how many fruits do we have in total? Or how many more oranges do we have than apples? Or in this case of the 3 categories, we could say, which fruit do we have the most of, or do we have the least of? We go into defining geometric attributes, such as the length of a side or the perimeter. We could get into area calculations. We go into identifying and comparing more shapes. So we ask the students to name what shape they see instead of asking what shape they want to see, or maybe even start to get into drawing more 3-dimensional shapes for a little bit more scaling up there. Combining shapes to create different objects. So we have this rectangle here with this triangle to start to represent a house, with a rectangle for the door, a circle for the doorknob, and so on. We go into partitioning shapes into equal shares, so we might have a circle, and then we might split that up into a number of little segments of that circle, or cut it in half. We might take a square and split it into equal sizes, or take a rectangle and split it into equal strips, and so on. So I'm going to click my back button now and dive through the second grade just a little bit, where we start getting into a little bit more object recognition and a little bit higher levels of working with numbers. So we start out with adding and subtracting within 20, a little bit of practice, repetition from previous years, go through identifying different equations and maybe coming up with the answers to it, kind of like we would in a normal traditional math class, but this time it's just using the computer and it'll tell you right away if you got the right answer. We go into solving applied problems with addition and subtraction, where we're saying things like we're decorating a Christmas tree. How many ornaments do we need to add to have some number? We might go into maybe a trick-or-treat type of setting where we have a number of different houses where each house gives a different number of pieces of candies, and you want to make sure you go to the house with the most candy. And so you have to take the robot and compare all these different numbers and then move the robot to the house that gives the most candy. Multiplying groups of objects, so starting to do multiplication in groups of 2 or 3. So we have 6 eggs here, which is 2 times 3, or 3 times 2. We could go then into up to 10, so we have 4 times 5, so that would be 20. We could do same thing, oranges in the box, number of squares in a rectangle by looking at this grid here. Lots of different ways to support this visual representation of what multiplication is in terms of addition. going into identifying odd or even numbers, seeing if a group of numbers is odd or even, understanding place value, and we have a bunch of different activities for finding the represented value by looking at these different place value images. Using place value in addition and subtraction, so additional visual representations of these different problems, going into more estimating sums and looking at identifying equations, measuring lengths and starting to get into a little bit more details with centimeters versus inches, starting to expand upon that and subtracting and adding different lengths, a little bit more complex working with time exercises, where we might have to do things like match the digital clock with an analog clock, so make sure that the digital clock here is reading the same time. Get into working with money, where we say each of these coins represents a different value, and then how are we going to add up to make sure we know how much money we have in total. Extensions of representing and interpreting data. Then we go into identifying and comparing shape attributes, like saying, all right, if we have all of these shapes, how many do we have in total? And so you could count them up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 shapes in total. How many of them are circles? You could count the circles. How many are squares? Count the squares. So with that in mind, how many triangles do you have left? And you could say, all right, there are 5 triangles remaining. You could go into counting the number of sides of a shape, and then doing things like, so once you have the number of sides, what shape is that based off of the number of sides it has? Quickly going back, I'm going to dive into our 3rd, 4th, and 5th grade curriculum, just really quick overviews. For 3rd grade, we have a number of different solving applied problems, building up multiplication and division using object recognition, going into multiplication tables, operations, and algebraic thinking. Using visual representations to help students understand the multiplication is a series or a repetition of addition, or division being a repetition of subtraction, for example. We'll go into things like measurement and data, where we say, all right, we have this clock, how much time is between this highlighted section, or identifying what the different values of the number of cats and dogs or different animals in this bar graph is. We'll go into tracing different objects, and really starting to, again, build up those same skills that we've started off in the lower grade levels. You will notice that the 3rd grade math here, this is still being built out at this time, so we're still adding activities constantly. If there's anything specific that you want to see in the very near future, you can always send us an email and request it, and we're normally pretty good about getting those requests in higher up on our priority list, and we'll do our best to support that there. Quickly going to look through the activities we have for 4th and 5th grade. We start out in 4th grade with operations and algebraic thinking, looking through different activities like finding pairs of factors, or working with multiples of 3, or finding prime numbers or the largest prime in a set. And there's all kinds of interaction to these activities, so that it's not just working with the numbers. We're giving visual representation, we're giving real critical thinking behind identifying what these concepts actually mean, which is huge for these elementary level students. We go into numbers and operations in base 10, working with fractions and starting to identify different fractions, working with a little bit more measurements and data, working on geometry, finding missing dimensions from different shapes, carving out shapes from another shape, so carving out triangles from this oval to create a pumpkin, and then getting into more repeated reasoning and creating hexagons using repetition of driving and turning a different number of times. And throughout all of these activities, we're building up. We're saying, all right, the students start out with little to no understanding of working with numbers or programming or addition, subtraction, basic arithmetic. And we're saying, all right, we're going to build from there. Start out with really, really simple exercises and add little bits onto it over and over and over. And so we're building their math skills at the same time as we're building their algorithmic thinking and their critical thinking, their problem solving, as well as building up their coding skills, because we're getting them used to this step-by-step idea of coding and thinking about how to repeat a lot of the steps that we are taking. Moving on just a little bit more, we have the 5th grade math here, where we start out with numbers and operations in base 10, go into some more visual representations of fractions. We go into identifying different geometries along different images and shapes, driving through a grid of city streets, starting to recreate different images, like drawing the Olympic rings, or plotting your name, starting to create little graphing points in a coordinate plane. So saying, all right, we have this point here, starting to draw a square in the coordinate plane, graphing ordered pairs, diagonals of squares, and getting into operations of algebraic thinking. And once again, these are still being built out and added. So please suggest any activities that you think you would use right away, and we will get them there as soon as we can. I believe that was just about all that I had to talk to for today's session. Really quick, before I jump off, I'm going to show just a couple of additional tips of fun things that your students can do while working through these elementary math activities. In the free curriculum portal at the top right, in this projects section that was also in the curriculum portal, in projects we have a number of exciting activities here where the students can get started with drawing, or start to create different ball games, or start to create animations, and just get a little bit more creative with the coding that they're doing. And doing things as simple as just starting to draw shapes really helps to build their object recognition, their understanding of X and Y coordinates in a coordinate plane, what the radius of a circle is for this smiley face, because that affects how big it's going to appear. And so there's all kinds of additional things in here that you can have the students work on, just to give them that little bit of additional experience and extra practice. So I want to say thank you all so much for joining today. I'm going to stay on the stream just for a little bit in case anybody has any questions or suggestions. Go ahead and put them in the chat. You can also email me at djryan@ucdavis.edu, and I will put that in the chat in just a moment. And once again, thank you. All right, I don't see any questions. So once again, thanks for joining. We're going to continue with another webinar tomorrow on, we're going to go through some of the middle school math curriculum. And then on Friday, we're going to do a more interactive, slow, guided lesson on creating your first online assessment, or not assessment, but assignment, and really going through a lesson with your students. So I highly recommend registering for that. That's going to be about a 2-hour session where we're going to go slow and work through it together rather than me doing a little bit more of a presentation like I've been doing the last couple of days. So if you're interested in that, be sure to register on our website, and we will see you tomorrow.